Assalamu alaikum. All right, I welcome you to our third lecture. And before we move to our third lecture, we really need to do a recap of what we discussed last time in our second lecture. Now, in our second lecture, we managed to talk about things like binding energy, and we dwell much on the principal quantum. We try to look at how electrons are being filled in the orbitals. We look at the maximum number of electrons that can be accommodated by each and every orbital. We talked about the four classes of orbital. We talk about S orbital, we talk about the P orbital, D orbital, and F orbital. And we clearly stated that the S orbital holds a maximum of 2 electrons, with the P holding a maximum of 6 electrons, and D holding a maximum of 10 electrons, and F having a space of a maximum of 14 electrons. Now, today we want to take a voyage to the realization of our third lecture. And the third lecture, we are going to discuss about the subatomic particles. Here we really need to know what are the subparticles within. Okay, how does the particle being divided into smaller subatomic classes? Now, we have our particle, and in reality, particle is always divided into two. And the division of the particle is either divided into matter, or it's being divided into force. Now, our matter is always referred to as the fermions, and the fermions are further divided into quarks and leptons. Then leptons is having some particles, and these particles, we have the upward quark, downward quark, we have the charm, we have the strange, we have the top and the bottom quark within the quarks. Now, in the leptons, we have the electron, we have the electroneutrino, then we have the muon, and then we have the tau. Of course, the discussion of this is not going to form the basis of what we are discussing now, but they are going to be of an obvious importance when we start discussing our advanced module, that is nuclear medicine. And then quarks are further divided into something called hadrons. Now, the hadrons is composed of the proton and the neutron. The nuclear can as well be called an hadron. An hadron is a composition of the protons and the neutrons. Then, when we come to forces, basically forces are only divided into 4 classes. Forces are divided into 4 classes. The first class, we have the strong force. Second class, we have the weak force. Third class, we have the electromagnetic force. And the fourth class is gravitational force. Those are the division of forces. So in terms of force, forces are also called bosons. And these bosons are divided into 4 classes, as you can see. The first class is gluon. This gluon is the strong force carrier. It is the strong force carrier. We have gamma, we have Z and W. These ones are weak forces. These two are carriers for the weak force. But gluon here is the carrier for the strong force. Now, W here being a carrier for the weak force forms a vital, important discussion in our when it comes to when we discussing the weak forces, how weak forces is able to influence the atomic structure in terms of features when we try to do the classification in terms of color. Because when we try to classify atoms into most subparticles, we talk about the mass, energy, we talk about the mass, we talk about mass, energy, maybe we can talk about how they are configured within their energy levels. But sometimes we leave leave out the so-called the color, and color is also a property that is contributed by the weak force, as we'll be able to discuss in our lectures. Now, it is important also to understand, as we have said, that we are not going to dwell much on the leptons, because leptons are not forming the basic part of our course. We are only going to deal more of quarks, and we discuss the forces. Now, it is important to realize that we have, I said that we have the upward quark, downward quark, we have the strange, we have the charm, we have the top and bottom quarks. Now, the subatomic particles, the boson are, we say that they are charge carriers in terms of the force the other side. Now, it is important to understand that the hadron, which is now our nucleus, composed of protons and neutrons. And what makes us know that this is proton and this is a neutron? Now, a neutron is having one upward quark and two downward quarks, as you can see. It has one upward quark and two downward quarks. Then when you come to the protons are having two upward quarks and downward quarks. And through influence of force, we can change the downward quark into upward quark, and that one gives us that is a weak force, and gives us a new property. In other words, it will be a production of changing a neutron to a proton with the emission of an electron, and that one leads us to a better particle decay, better negative decay, and that is also going to form a vital part when we will be discussing our advanced models. Now, quarks are nothing other than quanta of small packets of energy and masses, and the quarks greatly influence the property of the element, such as the color, as well as the nuclear reaction. And the properties we shall discuss them deeper. I've talked about the force and weak force and strong force. Now we have said that forces are the charge carrier for the forces, and we said that force is also known as bosons. Now, bosons are the charge carriers. We have the gluon, we have gamma, we have Z, and then we have W. I've said that gluon is a carrier for strong force. It's a carrier for strong force. And then we have gamma, and then we have W here. It's a charge or is a force carrier for the weak force. Now, as you have said that the force is categorized into boson, and it forms the weak force, and this it forms both weak force and the strong force. Now, these forces plays a key role in the stabilizing and stable nuclides by changing neutron into proton with the release of an electron. Because just like I've said that if a weak force is attached to downward quark, and then it turns it to be an upward quark, then when it becomes an upward quark, it means that now it's no longer a neutron, but it will now become a proton, because it will be having two upward quarks and one downward quark. Now, when it does that, it means normally it occurs to mostly unstable elements, and it means that that element will become stable at that particular point. Now, this force carrier is what plays the role in stabilizing the element, whereas the gluon plays a role in binding the electron, the neutrons together, and also bind the protons together. And this actually it is the force that is going against the repulsive force that is experienced by the by the by the protons. Remember, protons is positively charged, and if you have the protons now residing in a enclosed nucleus, then clearly we expect to have some electromagnetic repulsive force. Now, the force that brings these protons together, irrespective of the strong repulsive force within the protons, is the gluon here. This gluon is what binds the protons together and also binds the neutrons together. And this one is realized by the fact that it tries to bring in some glue kind of behavior between upward quark and downward quark. So when it tries to bind those upward quark and downward quark, then it makes it more stronger. And when it becomes stronger, it means that it withstands the repulsive force that we expect to be experienced in the nucleus. So that it means that this force here is more stronger than the nuclear force. It's more stronger than that electromagnetic force of repulsion that is experienced between the same charge, the same positive charge protons within the nucleus. Now, having studied that, we look forward to do something in our next lecture. In our next lecture, we will look at the strong force now, because we have studied the subatomic particles. We've looked at the subatomic particles. We have looked at the fermions, where we have classified them into leptons and quarks. We have talked about the quarks. I will say that quarks are further divided into hadrons. Those hadrons are nothing other than the nucleus. And the nucleus, we have said that it composed of two particles. We have the protons. Protons are having two upward quarks and one downward quark. Then we have the neutrons. The neutrons on the other side are having two downward quarks and one upward quark. And we have said that these quarks are held together by a strong force. And that strong force is called gluon, which is the strong force carrier. This gluon here. So I wish to stop at that point and see you in the next lecture, where we'll be discussing about the strong force. Thank you. Have a nice time.